Hi there, I am Anjan. I hope you are having a great day. Today I'm going to clear up things, how JavaScript works under the hood, and also I will try to break our code to see how those codes are executed in both synchronous and asynchronous behavior inside the JavaScript engine. So some of people may think like JavaScript auto runs this code behind the scenes. Inside the browser is. So why do we even need to care about it? But that's not the actual case. Knowing these things help you to understand the code much better and makes it easy to solve a lot of bugs and problems, ultimately making you a good developer. Yes. So let's dive in. I have here index.html and app.js linked with app.js, and let me first write a really simple code here. Before writing more codes, let me first explain the JavaScript runtime environment. So if you consider this whole box as a JavaScript environment in your browser, so inside this environment we have JavaScript engine, which will handle all the memory allocation as well as synchronous actions. And also I would like to tell that every browser has their own built-in engine. For example, Google Chrome has V8 engine for JavaScript, and this JavaScript engine further contains two main components. One of them is memory heap. So this memory heap is responsible for all the memory allocation that happens for our program. For example, I just declare the variable here, variable A, B and C. So now JavaScript engine has already allocated the memory for those variables in this memory heap in different address, and now the JavaScript engine remembers. So we just use the memory heap here. So for example, this is for variable A, B, C. And another main component is call stack or execution stack. This is responsible for reading and executing our scripts in a synchronous manner, means one at a time in order. This stack first puts the scripts in call stack. In order, they are invoked in the program and starts executing them, and after they are executed they are removed from the stack. So this works in the principle of first in, last out. First to in will be the last to out. Let me clarify this with this example. In this example, I have three functions, 1, 2 and 3, and function 1 executes first. so it is invoked first. So it stays in the bottom of the call stack, and function 1 again invokes function 2. So this means uh, the program flows to the function 2, and the function 1 haven't finished its work yet, because it flows to function 2 now. So function 2 prints out 2 in the console, and so and again it invokes the function 3. So function 1 haven't finished its work yet, because it is at the bottom of the call stack. So after function 2 is invoked, it stays, it pops in the call stack, and after function 3 is invoked in function 2, function 3 again pops in the call stack. Now function 3 will print out 3 in console, and there is nothing left to do. So when there is nothing left to do, or the function returns, that function is popped out from the stack. So function 3 will now pop out from the stack. Now function 2 also have nothing to do, so function 2 will also pop out from the stack. Now what is left is function 1. Function 1 still have to print this line, console.log1. So it prints the line 1 in the console. So here is our output, 2, 2 and 3 and 1. So you can see this is the stack. After this 1 is printed in this screen, nothing is left to do there. So this also, function 1 also leaves the stack. So now the stack is empty. So now we can handle various asynchronous tasks here once the stack is empty. And also I would like to show something cool here. When this stack gets bigger and bigger, and there is one limit, we call it as stack overflow. In this limit, the size of stack will be like exceeded, and for example, so in this code snippet, the overflow function calls itself. At first, overflow is it goes in the stack, and it again adds itself in the stack, and it again adds itself in the stack, and this goes on and on, and as a result the stack gets bigger and bigger and bigger. So this may result to the stack overflow. Let me run it. So it says maximum call stack size exceeded. So here this stack size is exceeded. As it reaches this maximum limit, and here is exceeded. And the problem with this is it blocks our other program. For example, so this program is no more executed here, so it blocks it. So that's why we need some kind of uh, asynchronous behavior in our program uh, to handle this kind of things. For example, as you know, JavaScript is a single-threaded language. So what if we have to run uh, big tasks and big program, and in in one of the in one of the code block, uh, it keeps looping and looping, so it blocks other codes. What if we have to loop through the million of items? So in this case, we need some kind of non-blocking non-blocking technique, that is asynchronous programming. So let's move into the asynchronous programming. As you already know, JavaScript is the single-threaded synchronous language, and it blocks the execution of the rest of the code if one of the current block of code takes longer. So when we have to do something like API calls, image processing, then we need something more than just synchronous task. This could be huge problem, as it would decrease the speed or performance of application drastically. So here comes the application of asynchronous programming in Rescue. We can make the use of asynchronous programming here in order to increase the performance of our application. For example, when we are doing some kind of API calls or having some kind of events, then we do those tasks outside of the scope of single-threaded JS engine, and add those asynchronous tasks in the event queue. And after we add in the event queue, this event queue is going to check frequently whether the execution stack is empty or not. So if the execution stack is empty, it will send or add the function that is to be executed in the stack. For example, like this function click handler. So for this click event, we may have click handler, and for this, after this finishes, this pops out from the stack, and for this load event, it goes in call stack also, and after finishing everything, this call stack ultimately becomes empty. So this is how JavaScript engine works. And so let me show you one example in which I have one function that is going to wait 3 seconds, and it is executing fast. So it is going to wait 3 seconds before it runs other program. So and only after then uh, all the other programs will be executed. So in that 3 second, if I if I click if I click in the web page, click events appears at last. This is because of the asynchronous nature, and because the event queue only enters to the call stack once the call stack is empty. So once it executes all these programs, and then only it will execute this click event here. So what I mean to say is rest of the execution must be completed, and the execution stack must be empty in order to execute those function in the callback queue. I just try to explain general idea in surface level you need to know, and there might have been some flaws in my presentation, as I'm not used to in making these kind of presentations. So I hope you will consider it. Thank you.